All right, today we're working on lesson 3.12 in math. The title is Choose a Method. And our essential question is, which method could you use to find decimal sums and differences? So we're just going to talk a little bit about some ways that we can set them up and do them. Here is our first problem. At a track meet, Stephen entered the long jump. His jumps were 2 25/100 meters, 1 81/100 meters, and 3 75/100 meters. What was the total distance Stephen jumped? Use properties and mental math. So we're going to add the 2 25/100 plus 1 81/100 plus 3 75/100. The first thing they have us do is to use the commutative property, and they exchange the 3 75/100 and the 1 81/100. Why would they do that? What's the whole deal with the commutative property? Why would we use it, Danny?
Because 3 75/100 and 2 25/100 goes even.
Not into each other, but when we add them, we're going to have a whole number, an even whole number. And so then they have parentheses. Okay, so we use the commutative property to switch a couple of our numbers around. Now we're going to put some parentheses in so we know what to add first. That will make it easier for us. So we're going to take our 2 25/100. Sorry, that's really messy. Let's try that again. 2 25/100 and add 3 75/100. Okay, so we're going to go ahead and add our 2 25/100 and 3 75/100. What is 75/100 and 25/100 add to? B. What? 1. And what is 2 plus 3? 5. Plus the 1 from our hundreds. So now we have 6 here, the whole number 6. And that's a lot easier to add than the hundreds. So 6 plus 1 and 81/100 would be what? 7 and 81/100. So we used our commutative property to rearrange our numbers, and then we used the associative property to put in our parentheses, and that made it easier for us to add. Okay? Another way, we're still talking about Stephen and his long jump lengths. So you can stack them one on top of the other and add vertically up and down. What is the most important thing when we add one on top of the other?
With your decimal.
That your decimal stays lined up from top to bottom. Okay? So now we can add the numbers in the hundredths column. I look at this and I say 5 plus 5 is 10. Plus 1 more is 11. We group by 1. I look at this and I say 8 plus 2 is 10. 7 plus 1 is
10.
And 10 plus 8 is 18. Decimal point, we group a 1. I look at this and I say, well, 3 plus 2 is 5. Plus 2 ones is 7. So I get 7 and 81/100 meters. All right, now we're going to try another way, and this one, if you look over in your box, is subtraction. In 1924, William DeHart Hubbard won a gold medal with a long jump of 7 44/100 meters. In 2000, Roman Sharenko won the bronze medal with a jump of 8 3/31 meters. How much longer was Sharenko's jump than Hubbard's? First use place value, then use a calculator. So we're going to do our one with place value first. Can we subtract 1, take away 4?
No.
No, so you've got to do some regrouping. Your 3 becomes a 2. We add 10 to your 1, so you now have 11 minus 4, which is
7.
7. Again, we can't have 2 and take away 4, so we're going to have to go to our 1's place and regroup. That allows us to have 12 minus 4, which is 8. Bring down your decimal point, and 7 minus 7 is 0. Okay, we're going to try that out on a calculator. Here's our calculator. So we're going to put in 8. Don't forget to go down and touch your decimal point. 8 3/31 minus 7 44 equals 0 87 So Sharenko's jump was 87 meters longer than Hubbard's. Okay, you'll see right down below your A and B box there's a question. It says, explain why you cannot use the commutative property or the associative property to find the difference between two decimals. If I regroup my numbers when I am subtracting, I'm not going to get the same answer as if I add, right? There's no commutative or associative property of subtraction, only of addition and multiplication. So I'm going to go ahead and type in the answer for that explain. Okay, so when you subtract, if you change the order of the numbers or you group the numbers in a different way, you do not end up with the same answer. Okay, so we took 4 1900ths and we added 5800ths and we got 4 7700ths. Now on number 3 on your paper, you can do some commutative and associative property here. Why would I put 5 7/10 and 1 3/10 in parentheses, move them and put them in parentheses? Why did I do that? Because the tenths makes one whole. So if I have one whole in my tenths, and I have one whole here, that makes how many holes?
7.
If I have one for my tenths and one here, that makes 2. I add my 5. So now I have 7 whole, or 7 ones. And I still have to add 2 2500ths. So then I have 9 2500ths. Okay, let's try, this is number 6. Now notice we're subtracting, so we can't use any of our properties, so we're just going to stack it up. And we're going to have to do some regrouping because we only have 400ths. We cannot take 600ths away from that. So 14 minus 6 is 8. Again, I can't take 300 or 3/10 minus 8/10. So I'm going to have to go to my ones place. Now I have 13 tenths minus 8/10, which is 5/10. No regrouping needed here. 7 minus 5 is 2. And 3 minus 2 is 1. So I end up with 12 58 hundredths. Okay, I found another one where we can use our properties. It's on page 153. It's number 15. Which two of these can we group together to make our addition easier? Tegan?
6 and 3 times, and 7 times.
Okay, and why do you think that will make our addition easier?
Because 7 plus 3 times plus 7 times equals 1.
One whole. All right, here we go. So let's group them. And she said 3 plus 7 makes 1 whole. So I would have no tenths. So I would have 6 plus the 1/10 from my 6 plus the 1 from regrouping my tenths. So I would have 7 plus 7, which is 14, right? Plus my 2 and 98 hundredths. Well, 14 plus 2 is 16 and 98 hundredths. Okay, so this one is a little bit different than the one we just did. Why it's still the first number in our equation that we're looking for. It's addition instead of subtraction. So we can take our sum. We're going to take our 62 and 4/10, and we're going to subtract 31 and 53/10. This will allow us to get our factor, which is what they need for n. Now, we don't have anything in our 62 and 4/10 in the hundred spot, so let's put a 0 in there to fill that place value. Now we're going to have to do some regrouping. So cross your 4, and that makes that 3, and you add 10 to 0, which gives you 10 minus 3 is 7. And again, we can't have 3 minus 5, so we're going to need to go to our ones place and regroup. That gives us 10 to give to the tens place. 13 minus 5 is 8. Now we can here, 1 minus 1 is 0, and 6 minus 3 is 3. So n is equal to 30 and 87 hundredths. And if we want to check that, we can add them back together. And we would see that 7 plus 3 would make a 0 in our hundredths place. Then we would have to regroup a 10. So 5 plus 2 plus 1 in our tenths place would be 8. And then 3 plus, then with my regrouped 1 from the tenths, I would have the 1 in 31 and 53 hundredths plus the 1. So I would get 2, and then my 3 plus 3 in my tens place makes 30. Okay, there is one more of these, so let's try it. Now we have 3 numbers. So we're going to have to do a little bit more work here. So what's the first thing you would do? There's really 2 ways you can do this. Stephen, what would be the first thing you would do? Add what are we going to add?
9 and 2/10 to the 8 and 4/10.
Okay, so let's add 9 and 2/10 plus 8 and 4/10 to get 17 and 6/10. Once we've done that, what are we going to do? Subtract it from 20 and 8/10, right? And we would get 3 and 2/10.